Hi. So in this session we are going to start with a new topic, that is linked list. Okay. So what linked list is? Before going on to that, let us see that how can we store multiple elements. So we already know one way, that is a list or an array. So list stores how? It stores in this way that if you have a list like this, let's say 3, 2, 5, 4, 1, you have a list like this, and it has an index saying that this is my 0th element, this is my first, second, third and fourth. So if list has 5 elements, my indexing goes from 0 to 4. So if list has n elements, my indexing goes from 0 to n minus 1. Okay, and all of these elements are stored continuously in a list. Okay, that this is my 0th element, after that this is here, after that this is here, after that this is here, after that this is here. Okay, so this is how list is storing all the elements. So that's a great way. Now we are going to learn a data structure which will store the elements but not in a continuous manner. Okay, so it will store how? Let us see. So in this, the list will be like this. If you have a 1 here, let's say I have elements 1, 5, 4, 3, 2. So something like this. 1 is connected to 5, then 5 is connected to 4, then 4 is connected to 3 and 3 is connected to 2. So this is actually known as a linked list, that there is a link between the elements, and each element of the linked list is known as node. Each element of the linked list is known as node. Okay, how these connections have been made, we will discuss about that, but till now what we have learnt is that this is kind of linked list, that after 1 5 has come, after 5 4 has come, after 4 3 has come, after 3 2 has come, and it has stopped here. Okay, so and each element of this linked list is actually known as node. Okay, so let us see that how will we construct this linked list. Okay, how will we storing this linked list. Okay, so for that we will see that if we have elements like this 1 5 4 3 2, first one will come and we will create a memory here and we will store 1 in that. Okay, okay, so if 1 has been stored here, now the next element which has come is 5. So 5 will be stored somewhere in the memory. Okay, let us say 1 has been stored at reference 200, 5 can be stored at reference 100, then 4 has come, 4 will be placed at some memory at available space, so it can be stored, let's say, at reference 300. Then 3 has come, so 3 can be stored here and it has been stored at reference 900. Then 2 has come, so 2 can be stored at reference, let's say, 500. Okay, now we have stored all of these elements but we have not connected them. Okay, the important step is to connect them. So how will we connect them? I think the easiest way to think is that we will see like this. One is here, but one will store two things. One is the data. This actually is a node because this is a node. So node will store two things. One is the data, which is actually 1. Here the data is 5. Here the data is 4. Here the data is 3. Here the data is 2. So node will store two things. One will be data, which represent the value of this node, and another will be reference to the next node. That means one will store that its next is 5. So 1 is storing here and it is storing the reference to the next node, that means 100 here. So now 5 will store what? 5 will store its data, that means this node will store 5 as its data and it will store the reference to the next node, that means here 300 will be stored. After that a new node will be there in which 4 will be stored, and in 4 reference to the next node will be stored, that means 900 will be stored here. Then there is a 3 here, 3 is here, its data is 3 but it will store the reference to the next node, that means 500. Now 2 is here, that means data is 2, reference to the next node is nothing, so it will store none. It will store none. Now you have connections like this, that one knows that its next reference is 100, so it will go here and it will go to 5, then it will go to 4 because it is storing the reference to the next node. So 4 has been here, so it has been storing at reference 300. This has been at 900. This has been at 500. So this connection has been made through references, and this reference is 200. Okay, so this is how we are able to build a connection that node is storing two things. One is the data and one is reference to the next node. Every node will store two things, one is data and another is the reference to the next node. If each node node knows these two things, then I think we can construct the linked list. Okay, so let's see what we need in case of a linked list. So we had constructed the linked list like this 1 5 4 3 2. So it has been constructed like this: 1 here, 5 here, 4 here, 3 here, and 2 here. Let's say its reference is 400, its reference is 600, its reference is 800, its reference is 1000, and its reference is 200. So it will store the reference to the next node, that means 400 here. It will store 600 here. It will store 800 here. It will store 1000 here. It will store none. Okay, so this connection has been made like this. So this is how linked list, that means all these nodes has been connected. So these nodes have been connected like this. Now what we need in case of linked list, I think we need the reference to this node. Let's say its reference is 100. If we have the reference to this node, we can go to this node through this reference. We can go to this node through this reference. This is 600. If we know the reference to this node, we can go to the next node through this reference. So, but I want the initial reference because 100 has never been stored anywhere. Okay, so that reference is actually the head of the linked list. Head of the linked list stores the reference to the first node. So that means this node, this is a 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 node. Reference to the first node is actually the head. Okay, reference to the last node is actually known as tail of the linked list. Okay, but we don't actually deal with tail much, but we deal with head too much and too much. So we will say if I have the reference to the first node, that means if I have the head of the linked list, if I have the head of the linked list, then I have the complete linked list, because I can go from here to here, then I can go from here to here, then I can go from here to here, then I can go from here to here. So I can traverse the complete linked list if I have the reference to the first node, and that actually known as the head of the linked list. So that means you are given a linked list, that means you are given a head of the linked list. If you are given a head of the linked list, that means you have a complete linked list. Okay, so this is how we will be storing things in the linked list, that for linked list we will maintain a node and each node will have two things, one is data and one is next. There is a special terminology that reference to the first node is known as the head, reference to the last node is known as tail. Okay, so this is what is linked list is. That means connection of these nodes like this, and how connection has been made through references. Okay, and reference to the first node is known as the head of the linked list. Okay, so in the next part we will be starting doing some coding. Okay, and we'll deal around nodes. But for now you should have a basic understanding that what a linked list is, how can we store multiple elements in a linked list, and what is the head of the linked list. Okay, so we will meet in the next session and do some coding part related to this. Okay, great, thank you. Hi, so in this session we are going to start doing some coding. So what we do in a linked list, I think a linked list is a collection of nodes, and every node had two things. One is a data and one is next. Okay, so if I have a, it has a data 14 and its next can be a B here whose data is 16 and whose next can be none here. It will store, A's next will store the reference of B, that means if it has 200 then it will be storing 200. Okay, so data stores the value and next stores the reference to next node. Okay, reference to next node, and if there is no node present, then that means next will be none. Okay, so what we can do here is that we will have a class node for a linked list. Okay, like this. So every node will have two things, that is data and next. Okay, so whenever we will want to initialize our node, we will provide a data with that. Okay, with whatever data you need to initialize, you need to provide the data. That means if you want to initialize a node with value 14, so you will do what, that I will create a node, its data is here, its next is here. Okay, if in data I will store 14, you need to provide that data for creating any node. By default I will store next to be none. Okay, so I will create a node like this whose data will be this value and whose next will be this. Okay, by default it will be like this. So what I can do here is that I need to maintain two things. That means my data will be the data provided by this, which comes in this constructor, okay, and I can do self dot next to be by default, okay, it is pointing to none. This is how I have created my node class. Whenever I want to create a node object, I need to provide a data with that, okay. So let's say I do like this, a is equal to node, I provide the data 30, okay, and I do b equal to node 15 like this. Then I do a dot next equal to b. Then I try to print a dot data. I try to print b dot data like this. Then I try to print a dot next dot data like this. Let's see this what will happen. Okay. So I have initialized like this, a equal to node of 13. So a will be made. This constructor will be called. In this data has been passed as 13. So in a, data field will be filled with 13 and next field will be none by default up till this point. Then b equal to node 15, that means b will be created, 15 will be here in data field and in next it will be none like this. Then I do a dot next equal to b, that means in a dot next I store the reference of b, that means here it is, let's say 200, so I will say it is not none now, I am putting 200 here, okay. So I have put 200 here. Then I try to print a dot data, so I go to a dot data is 13, I go to b dot data, that means b dot data is 15. Then I go a dot next dot data. This is interesting. A dot next is here, a dot next I will go to b, I had gone to b here, b dot data, this is data, this is next. So a dot next, through a dot next I had gone to b, I had printed b dot data, that means 15 will be printed here. I think my output will be 13, 15 and 15, okay. So let's see what will happen. So if I run this, my answer is 13, 15 and 15, okay, that is quite correct. So let's work around on little bit things more. Let's see, if I try to print a dot next dot data is fine. Let's say I try to print a, okay, and let's say I try to print a dot next here and try to print b here, okay. So when I run this, as you can see, this is node object at address this. This is node object at address this. This is node object at address this. Both of these are same. That means what? So a was here with data 13 and reference of b. B is here with data 15 and none here. A dot next you did b, so that means 200 was shared, so you stored 200 here. You had printed a, so it prints the reference of this. That this is a node object at this address. Then you print a dot next. So a dot next will print this, that is exactly this, and you try to print b, that is exactly this. So both of these are same, so that means they have the common reference. Okay, so that means a dot next is same as b. Okay, and one more thing, if I try to print like this, print b dot next dot data. Okay, b dot next dot data. So what will happen in this? Let's say I comment it down. I try to print b dot next dot data. It is giving me error that none type object has no attribute data. Why? Because you had made your connections like here. A is here, 13 is here, and reference of b is here. Let's say b is 200. You had b 15. This is none. You try to access b dot next. So this is your next, b dot next dot data. It is giving you error that none type object has no attribute data. So it is of none type, so it has no attribute data. That means no data is present in none. Okay, so it will give you an attribute error that it is not able to find the data field in this attribute, in none attribute. Okay, so it is not able to find attribute data in none. Okay, so that is fine, and that actually makes sense. Okay, so this is how the references have been made. This is how we will make connections in a linked list, and this is how we will be creating the linked list. Okay, because linked list is all about the head of the linked list. If we know the head of the linked list, that means we know all the other elements of the linked list, and each element of the linked list is of type node, and accordingly each node has a data and a reference to the next node. Okay, so from the next session we are going to start taking input of the linked list. We are going to start constructing the linked list through some input and all. So make sure you understand this, that what is a node, what is a linked list, what is the head of the linked list, and all of these, how these references has been made, how these will be connected in case of linked list. Okay, so we will be start coding in the next session. Okay, great, thank you. Hi, so in this session we are going to start taking input of the linked list from the user and going to print the linked list whatever we have taken on the input. Okay, so how will we be taking the input? So we will be taking input in a specific order. So it will be coming like this, space separated input in the order, like let's say I want to create a linked list 1 2 3 4 5. So it will create a linked list like this 1 2 3 4 5, and if this is the end of the linked list I will have -1. So there is a space separated input here, and in the end you got -1. So at -1 you need to stop. So for the rest of the elements you need to create the linked list like this. Okay, so how is your input? This is a space separated input, and you have to take input until you get -1. Okay, so your last element will be -1, the rest will be taken as a space separated input. Okay, so how can we take this as an input? I think this can be taken as a string in Python. Okay, this whole string can be taken as a string. So if I take as a string, I want to split it on the basis of space. Okay, I want to split because my delimiter will be space. It will create a list like this of characters, because it has a string, that's why it will create a list of characters. But what I want is, I want a list of integers. So I can use the concept of list comprehension, that what I will do is, I will do input, this will take the input of the string, it will do split will do what, this will split like this, space separated input, and it will split and convert it into characters. I will go to each element in this, for element in input dot split, it will go to each element, and I will store the integer part of that element in a separate list. So I can do this only in one line using list comprehension, that get me the integer part of each element from this list, and this list is for element in input dot split, which will be like this. So I got the integer part of 1 2 3 4 5 and -1. So this is how my list will be generated, like this 1 2 3 4 5 -1. We can convert this to here directly using one line, using the concept of list comprehension, which we have already studied earlier. Okay, so let me take this input first. Okay, so whatever task will be to take the input of a linked list, and I think input of the linked list means you need to get the head of the linked list, because you know every part of the linked list if you know the head of the linked list. So the motive of this part will be to get the head of the linked list. Whatever the linked list you have constructed, you need to get me the head of that linked list. Okay, so we will take the input in this, we will construct the linked list in this, we will make the connection in this, and after that we will return the head of this linked list. Okay, so I will implement this function. Right now I am writing pass only. So I will get a head through this take input function. This is our motive. Now our task is to implement this function take input. I think the first task is already done, that I will get the input list using this for element, sorry, integer part of the element. And how will I get the element? Using this for element in input dot split. I want to get the integer part of the element through this, and this is what list comprehension does. It goes to input dot split, you give a space separated input, it splits on the basis of space, it creates a list of characters, and you get the list of integers in one line only, like this 1 2 3 4 5 -1. It goes with a for loop to each part of this list and get you the integer part. Now you need to go to each element of this list. So you got a list like this 1 2 3 4 5 -1. For all the nodes, all these elements you need to create the linked list nodes, that we have already know that what a node is. A node is something which stores data and the next. So we will be creating for all of these nodes, we will be making connections, and how connections will be made, we will be traversing on this list. Okay, and we will keep on traversing until we got -1. Okay, so how can I iterate? I can iterate on this, that current data in input list, I will be iterating on this list. Okay, so I am going to each part of this list 1 2 3 4 5 -1. The point is, First current data will become 1, then current data will become 2, then current data will become 3, then current data will become 4, then current data will become 5, then current data will become -1. So at -1 you need to stop. So add, if current data becomes equal to -1 at any point of stage, you can just break out of it. Okay, you can just break off the loop and no need to work further. For the rest of the part, we need to work. Okay, and the first part of the work which you need to do is, when I get this element, the first foremost task is to create a node corresponding to that. I will create a node. A node will have two things, a data and a next. When I pass this data as in this argument, so it will create as this and next will be none. So I want to create this node, and how can I create this node? Like this. When I come to this inside this for loop and current data is not equal to -1, my new node will be, I will pass this data in the node, like this. So I have created this node. For this node I have created. Similarly, when I come to 2, I will create a new node like this. This will become like this, 2 and none. Then I go to 3, 3 will do like this, 3 and none. So for now, just nodes will be created. You had not made any connections. But the foremost important part is what you need to return out of this function. I think we need to return the head of the linked list. And what is the head of the linked list? The first node of the linked list. Okay, so you need to have a setter that this is my head, or this is my head, or this is my head. I think head is the thing which comes first. Okay, if I give you only -1, then head is none. No one is pointing, that means no one is present in the linked list. That means in this case head is pointing to none. If I give you 1, 2, -1, so whatever node you have created for 1, that will be your head. That means like this, 1 and reference of 2 will be there. Let's say 2 is here, reference of 2 is 200, 200 is here. Let's say reference of 1 is 100, so head should store 100. Okay, so reference to the first node you need to maintain. If no element has come, so that means if only -1 is present, that means head should be none. Okay, so for that what we can do is that before going to each part of the list, I will initialize my head to be none. Okay, if current data becomes -1, I just break out of the loop, and in the end I just need to return head after all work. This is my motive of this function. I just need to return the head. Okay, so head initially is pointing to none. If no input has been there, that means head is only none and I will return none. If some input is there, then I need to return the reference of the first node. And how will I know that this is my first node? So if I have elements like this 1, 2, 3, 4, 5, -1, you had first created the node for 1. So that means before creating this node, you know that your head was pointing to none. After creating the first node, head will start pointing to 1. So when 2 will come, your head will not be none. Head will be pointing to 1. So your toggle point is that if head is none, that means it is your first node which is coming up. That means your head is getting changed. If second node, third node, fourth node, fifth node is coming up, that means you don't need to change the head. Okay, so what you can say is that my head will change if after creating this node, if I know that my head was none before this node. If head was none, that means what? That means no node has been created up till now. This is the first node which has been created, and I should say that my head should start pointing to this node. My head should start pointing to this node, not for the second node, not for the third node, not for the fourth node, not for the fifth node. It should only work for the first node. That means if head is none, that means it is the first node. That means I will change my head to this new node. For the rest of the nodes, I will not change my head. For the rest of the nodes, I will not change my head. But I need to do the work for the next of the nodes. What work? I think we need to make the connections. Let's say my input was like this, 1, 2, 3, 4, 5, like this. So up till 3, we have created the list like this, 1, 2, 3. Now 4 has come. What you do is, current data is not equal to -1. You create a node for 4 like this. 4 and next will be none. Head is none. No, head will be pointing to this. So you need to go to the last part of this linked list. You need to go to the last part of the linked list. So that means you need to go from here to here, and after you come here, you need to make connection. That means if 3 was like this, 3, before going to that, 3 was also pointed to none. Now when 4 had come, how will you make this connection? That 3 is next. This is my data of 3. This is my next of 3. That 3 is next to store the reference of 4. That means if this is 600, 4's reference is 600, I will store 600 in next of 3. Okay, so how will I reach 3? I can only reach 3 using this head. But the point is I cannot change this head. That means if I try to reach the last part of the list, and how will I reach that part of the list? Let's see. So 1, 2, 3, up till now this has been created. I have created a node for 4, 4 and none. My head is like this. Head equal to head dot next, I will go here. Head equal to head dot next, I will go here. This is my 3. Head dot next equal to this reference, the reference of this new node. Okay, I will write like head dot next equal to new node. If I do this, then after this what it will become is, for the next part 1, 2, 3, 4 has come here, my head will become what? You have done head dot next equal to new node, that means your head has become like this. You have lost the reference to the first node, because while connecting 4 to 3 you had shifted your head, that means you lost the reference of the head. You cannot go previous, you cannot go back. So how will I get the reference of the first node now? So I cannot move head after this. I need to maintain that this was my first node. So I cannot lose the reference of head. So head should stay here only. What I can do is I will maintain another reference while traversing further. Okay, I will not change this head, because if I change this head, my head will become like this. For the next part I will make the connections 3, 4, 5. My head will move after this to here, but the point is your head has changed. That you cannot make it happen, because we cannot lose the head, because we need to return the head. So we cannot change the head. Head will only be pointed when the first node had come. For the rest of the part you need to use some other reference. And how can you use that reference? Let's say this is 1, 2, 3. Your head will remain always here. Now 4 had come, you had created the node like this. 3 is here, 3's reference currently is none. 1 is here, 2 is here. You will maintain another reference, let's say current. What you will do is, while current dot next is not none, that means what? Current is still here. Current dot next is 2. Current dot next is not none, you will go to 2. Now current is pointing here. Current dot next is not none, that means this is not the last part of the linked list, because you need to connect 4 to the last part of the linked list. So current dot next is not none, that means you will move your current here. You will move your current here. Now 3 has come. Current dot next is none. That means you need to make connection with this node. That means what you will do is, you will do here that current dot next equal to new node. Now what it will does is, it will store the reference of this. Let's say this is 600, it will store 600 here. Now you had made connections like this, 1, 2, 3, 4. Now let's say 5 had come. You will first get the node for 5. You will start from ahead again, because you had maintained head to the first node. You will say that my current is pointing to this. Current dot next is not none. Current equal to current dot next. You will go here. Current dot next is not none. That means you will move here. How? Current equal to current dot next. Current dot next is not none. That means you will move here. How? Current equal to current dot next. Now here current dot next is none. So you will say that current dot next store this new node, and you are done. You have made connections like this. So you need to traverse the linked list, but you will not use the head for that. You will use some other reference. Let's say current is that for us. Okay, so what I am suggesting here is, except for the first node, you will not work on head. If it is not the first node, what you will do is, you will start from a head, current equal to head. You will keep on traversing till your next becomes none, because you need to reach the last part of the linked list. So that means you will keep on traversing till current dot next is not none. If it is not none, so what you will do is, you will keep on going to the next node, current equal to current dot next, current equal to current dot next. After that you will reach to the last node. What you need to make is that, hey, store the reference of the new node in current dot next equal to new node, and I think this part is over for the rest of the nodes. You have made connections through this, and I think this will take the input of whole linked list. Okay, so let's see what is happening for each value. So let's dry run this. 1, 2, 3, 4, 5, minus 1. We will create a list like this. Okay, now when the first input has come, current data equal to minus 1, no. So what you will do is, new node equal to node of current data. That means 1 has been created whose next is none. Okay, so this has come. If head is none, yes, head is none before this. Head was none before running any part. So you will store the reference to this, that means head will start pointing to this, head equal to new node, else part will not work. Now you know will go upwards, current data will become 2. When 2 has become, so what you will do is you will create a node for 2. So what it will become is, it will become like this, 2 and none. This is new node. Let's say its reference is 300. Now head is none? No, head is not none. Head is pointing to this. So you will go to the else part. Current equal to head. That means current will start pointing to this. While current dot next is not none. Sorry, current is equal to head. That means current will start pointing to this. Current equal to head. While current dot next is not none. Current dot next is none. So you will not go for the further part. You will do current dot next equal to new node. That means current dot next will not store this. Current dot next equal to new node. That means 300 will be stored here. So it will make like this. 1 300 and like this. So 1 to 2 has been made and 1 is storing 300 like this. Okay. So for the rest of the part we have done up till this 3, 4, 5, minus 1. Now what we will do is, current data is 3. Current data becomes 3. Up till now what has been done? 1 is here, 300 is it is storing, 2 is here and none is here. So this connection has already been made. My head will be pointing to this only. Current data is 3. So new node. First you will create node for this. That means 3 will be created like this. Let's say its reference is 500 and it will by default store none here. So first node for 3 has been created. Now head is none. No, head is not none. Head is pointing to this. Else you will reach the last part through this. So what you will do is you will store your current here. Current equal to head. While current dot next is not none. Current dot next is not none. Current equal to current dot next. So current equal to current dot next, that means 300 is here. You will move current here. Now current dot next is not none. No, current is dot next is none. So what you will do is you will stop. Current dot next equal to new node. This is the reference. So none will not be here. After that 500 will be here and this has been done. So up till now what has been done is 1 300. It is pointing to 2. 2 is storing 500 and it is pointing to 3 which is storing none. Now let's say 4 is here. 4 will do what? When you do, so first 4 will be created with none. This is my current data. New node has been created. If head is none, no, head is pointing to this. Okay, current equal to head. So your current will be pointing to this. While current dot next is not none. Current dot next is not none. Current equal to current dot next. That means you will go to 300, which is this. Current will be this. Current dot next is not none. Yes, it is not none. You will go current equal to current dot next. That means current will move here. Current is here. Current dot next is not none. Current dot next is none. So you will stop. After that what you will do is current dot next equal to new node. Let's say its reference is 700. So 3 will be storing 700 now and this connection has been made. Okay. So your node has been connected like this. Up till 4 it has been done. Now the next part is 5 has come. So 5 has come. So 5 first 5 and none will be created. This new node will be created because current data is not minus 1. You will go down. If head is none, no, head is not none. Current equal to head. You will start again current from here. Okay, current is none here. Current is pointing to this. While current dot next is not done. Yes, current dot next is not done. Current equal to current dot next. You will go here. While current dot next is not done, current dot next is not done. So you will move current here. Current equal to current dot next. Current dot next is not done. Yes, it is not done. You will move current equal to current dot next. So your current will move here. Now you have move here. Current dot next is not done. No, current dot next is none. So you will stop. Let's say its reference is 900. After that you will do is current dot next equal to new node. So it will store 900 here and it will go upwards. This connection has been made. Current data equal to minus 1. Yes, current data equal to minus 1. You will break out of the loop. You will return head. That means you will return this. You have already made all the connections and your linked list is complete. You know the head of the linked list. You can traverse on any part of the linked list and this is what how can we take the input of the linked list. Okay, very simple procedure but not a great procedure. Okay, it can be optimized further. Try to think the time complexity for this solution, that how we have taken the input. So if you have taken the input like this, I think you will be able to realize that we can do a more better way. Okay, but please try to diagram this yourself. Try to see what is happening behind, what is this next, and all, how the connections have been made. I think if that part would be clear, rest part would be easier. Okay, so make sure you understand this. In the next session, we are going to analyze this time complexity of the solution and we are going to optimize it further. Okay, great. Thank you. Hi. So in this session, we are going to see that how can we print a linked list. Okay, so we have already seen a method to take input of a linked list. We have not optimized it. We will be optimizing it soon. But for now, let us see that if we want to print a linked list, how can we print it? Okay, so this was our code of taking input of the linked list. So this had taken input of the linked list like this. If we had given numbers like 1, 2, 3, 4, 5, minus 1. So what it had done is it has created a linked list like this 1, 2, 3, 4, 5 and it is pointing to none. This is will be our head and we got our head in this function from this function like this. Okay, when we call take input, we will get the head like this and these connections have been made. Now our task is to print this linked list. We want to print in the same order like this 1, arrow 2, arrow 3, arrow 4, arrow 5 and then none. If we want to print like this, then we got the head. Okay, so if we want to pass a linked list, what we will pass? We will pass the head of the linked list. Okay, so we got the head of the linked list like this. We are going to implement the function print linked list and we are going to pass the head of that linked list. Whatever linked list you need to print, you will just pass that head and the function will do what? It will print the linked list corresponding to the head. Okay, so our task is to implement the function print linked list like this. If we have got print linked list, this is my head. I need to print this linked list. I got the head of the linked list. So this head is different from this head. Why? Because this is a local function. This is a local variable of this print linked list. Okay, so if I want to print a linked list, I have a head which is pointing to this. Okay, so I will go start from here. I will go till where? Head will go to this, 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 then head will become none. How? Head equal to head dot next, 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 the head will become none. Now you cannot print anything. Okay, before that, how you can print? If I am pointing to this head is storing two things. What? One is the data, which is 1, and one is the reference to this. Okay, so you need to print the data. We will print the data, and how will we move? By using the concept of next. Okay, so at every position, once head is pointing here, I will print the data of this, then I will print the data of this, then I will print the data of this. So I have printed the data of this, I will also print the arrow. I will print this data, I will print the arrow. I will print this data, I will print the arrow. I will print this data, I will print the arrow. I will print this data, I will print the arrow. After that, head will become none, so I will print only none. Okay, so data arrow, data arrow, data arrow, data arrow, data arrow, and after that head will become none. In the end, I just need to print none. Okay, so I will be able to print in this order. How? This is the head which is passed. I need to do the work till this head does not become none, while head is not none. I will keep on iterating head equal to head dot next using this. But when I am present at a particular head, what I need to print? I need to print its data. So head dot data. Since I need to print like this arrow as well. So this is a string, this is an integer. We cannot do that. So what we will do is convert this head dot data into a string. And after printing one thing, we just need to end with the like this. Okay, so that it does not come in the next line. By default it comes in the next line. We have passed as an end so that it doesn't come in the next line. After that we are done. We are done with this loop. In the end, I need to print none as well, and after that we are done. We can just return after that. Okay, in the end we will just print none, and I think we are able to print this. So let's try to run this function and call this function for printing. While current dot next is not none, here I need to write us like this as well. So if I now write here what 1 2 3 4 5 6 minus 1, so I am able to print my linked list. This is 1 2 3 4 5 6 and none, and this is the perfect thing. We are able to print the linked list, and as you should know, if I call print linked list again here, this head has not become none. This is a local variable to this, so you will be able to print the linked list again because this is a different head and this is a different head. Okay, so how this is happening? This is happening like this. First you got the head, let's say 1 2 3 4 5 6. This is the reference 100 and you got the reference 100 in head. So head stores 100 from this. Now you come here, you call print linked list head. So a print linked list function has been made. In that, the head of the print linked list function, that means print linked list dot head, copy this reference, that is 100. Okay, so it is a local variable function, local variable of this print linked list function. Okay, so this moves on pointing. So this is 1 2 3 4 5 6. Here print linked list dot head is pointing here. Here let me call it outside this, so I am calling main dot head. So this is main dot head, you have called this. So when you had called this and you move to this function, here this head becomes what? Print linked list dot head. Now you do here, while head is not none, here it is pointing to print linked list dot head. So print linked list dot head is not none, you will move print linked list dot head equal to print linked list dot head dot next. So you will move here and you will keep on printing 1 2 3 4 5 6. Print linked list dot head equal to print linked list dot head dot next. So this is a local variable to print linked list and that is a local variable to the main thing. Okay, so you will keep on moving, keep on moving, keep on moving. This print linked list dot head will become none and you will print none. So you are able to print this linked list one time. After that you come back, this print linked list dot head will remove. You have called print linked list head again. So here the head is same. This is main dot head. Main dot head is pointing to that point only, that was 100. Okay, so you had gone to this. When you call a function, the copy is created and in that again print linked list dot head will be copied as 100. Okay, this is a copy which will be made in the local variable of the print linked list function. So this head will not change. This is a local variable to the main thing and this is a local variable to the print linked list function. Okay, so we are able to print it. Now this, our code is also working fine. Now the task is, the code is not optimized. Input is taking lot of time. Try to analyze the time complexity for this. We can optimize this time complexity so that it will take less time to take input of n elements. Okay, we will be discussing that in the next session. Please open your mind and try to see this, that what we can do to reduce its time complexity. Okay, great. Thank you. Hi. So in the previous session we have already seen that how can we take input of a linked list and how can we print a linked list. Now in this session we are going to analyze the time complexity for that. That whatever input method we had followed, what was the time complexity for that solution. Okay, so let's analyze it, what we have done. So I think if you are taking input, let's say for 5 integers 1 2 3 4 5 and let's say after that you give the input -1. So your linked list should have become 1 2 3 4 5 and none. Okay, so what you have done is, when the first element come, you do only one thing, that is create a node for 1 and assign head to that. Okay, so I think creating a node for 1 is order 1 step, assigning head to that is also order 1 step. So this is order 1. Now let's see next element had come 2. So what you do is, you create a node for 2 and assign it to the next of 1. Okay, this is what you have done. Now for 3, what you do is, till now your linked list is like this. For 3, you create a node for 3. Now you have only head like this. You need to reach the last node of this linked list. So you go from here to here. Then you check its head is dot next is none. You stop here. Then assign it to this. Okay. So I think this next has become like this. So you traverse for exactly 2 elements. For the previous, you traverse for 1 element, that this is the head dot next is none. So I traverse for 1 element. Here my head dot next has become none, like here. So I have traversed for 2 elements. Now this has become 1 2 3 and none. Now when 4 will come, what you do is, first you create a node for 4. Then you have a pointer which is head. You start from here and reach till the last node for this element, this element, this element. When you reach here, then your next has become none. So you have traversed for this element, for these 3 elements, and then let's say this name is current, you do current dot next equal to 4. Okay, you don't use head because you don't need to lose the reference of head, that we have already discussed. So 3 is next will become 4 and this linked list would have become like this, 1 2 3 4 2 none. So for the 4th element you have traversed for 3 elements. Now for the 5th element, what you will do is, you will create a node for 5, You will start from here, you will keep on traversing till you reach the last node. You will come here, you will traverse for 4 elements, and 4's next will be assigned to 5, and already 5 next is already pointing to none. So assigning next of anything is order 1 step. I think the only step which is getting executed and taking time is traversing for these elements. So when nth element will come, you will traverse for n minus 1 elements. You will traverse for n minus 1 elements. Okay, so how can we calculate the time complexity? I think for the first element you had done no iteration, so that is 0 step. For the second element which you have done, which we have iterated for 1 element, that 1's next is none, so you have iterated for 1 element. For the third element you have iterated for 2 elements. For the fourth element you have iterated for 3 elements. For the fourth element your linked list was like this, you start from here and traverse for 3 elements, 3. It will go and go on. So for nth element you will traverse for n minus 1 elements. This will take some time. I think if you analyze this, for taking input of n elements you have done total this work. Rest of the part was order 1. We will not include that. I think that traversing only is taking time. And how much time is this? If you take the summation like this, its summation is n into n minus 1 by 2, that is n square minus n by 2. For the longer step we can ignore n, that is n square by 2, and that is order of n square. So taking input of n elements cost you order of n square time. Okay, that is taking lot more time, because for taking input of 10 to the power 6 elements you are taking around 10 to the power 12 microseconds time. Okay, so that is not a great solution. We can optimize it further. Okay, for n elements input we can optimize it into order of n solution. Okay, the only step which is taking time is traversing for the elements. For the nth element you need to traverse for n minus 1 elements. For the n minus 1 element you need to traverse for n minus 2 elements. That is taking time. I think we can optimize it. I will keep that to you. Try to think yourself. We will be discussing that in the next session. Currently we have analyzed the time complexity. I am making sure that this can be optimized. Try to think yourself that how can we optimize it. We can reduce this iterating for n elements part, and try to think like this, and if you're able to do that, try to code it yourself. Okay, we will be discussing that in the next session. Please analyze yourself and please reduce the time complexity. Okay, great. Thank you. Hi. So in this session we are going to optimize our taking input part of the linked list. Okay, so we have already seen the time complexity for that, and we will optimize it. So let's see what we can do. Okay, so what we have done is, whenever a new element needs to be inserted, we start from the head again and reach till the last node. Okay, what I'm saying here is that if somehow I maintained a linked list like this, 1, 2, 3, none have been made, a new integer has come, let's say 4, what you do is you create a node for this, you start from this head. Okay, you use some other reference current because you don't want to lose the reference of head, because you need to return the head of the linked list. So what you do here is you start from this current, you keep on traversing till current dot next becomes none, because you need to reach the last node of the linked list. So you do current, if current dot next is not none, current will move here. If current dot next is not none, current will move here. Current dot next is none, so you will stop here. You will do current dot next equal to this node. Okay, whatever this new node is, you do current dot next equal to new node. Now this linked list has been made. So for the next part, again your head is pointing here. If new integer came, you again start current equal to head and keep on traversing till your current dot next becomes none. Okay, I think we can stop this traversing part, because whenever a new integer come, what you need is reference to the last node. You don't need to refer these in between nodes. You just need the reference of the last node. If you know the last node was 4, if you know the reference of this node, let's say you will not start from 1 again, you have maintained that this was my last node, let's say this was current, you will just do current dot next equal to this node, new node. And since this new linked list has become like this, 1, 2, 3, 4, 5, this will become like this. Your current was here. Since you have inserted like this, your new current will become this. Why I am saying here is because now this has become the last node. So if any new integer come, let's say 6, you create a node for that, your current is pointing to this, you do current dot next equal to this, and you will move your current to here. This is what you can do. You need the reference of the last node. Since the reference of the first node is known as head, let's say we have a reference of the last node and let's say we call it as tail. We will maintain a tail. So how can we maintain a tail? I think when we are inserting integers, let's say 1, 2, 3, 4, 5, 6, when first integer has come, you have maintained that head is here, and since there is only one element in the linked list, so your tail will also be pointing here. This is your last node as well. Now when 2 will come, what you will do is you will create a node for 2. Your tail is pointing here. The rest of the part, since head is not none, so you will not change the head. You will do only work on the tail. So what you will do is tail dot next equal to 2. That means you have created a new node for 2. You will do tail dot next equal to this new node. So once next will become 2, now you need to move tail here as well because your new last node have become 2. So what you will do is tail equal to new node. First tail dot next equal to new node, after that tail will move here. Now third integer has come, so you will create a node for that, new node. You will do tail dot next equal to new node. Tail dot next equal to new node will do here because tail was pointing here. Now your last node has become like this, so your tail will become this. So new integer has come, you create a node for that, tail dot next equal to new node and tail equal to new node. New integer has come, we will create a new node for that, tail dot next equal to new node, tail becomes equal to new node. So at each iteration you maintain the reference to the last node and that you have maintained through the tail. So whenever a new element comes, you do these steps, tail dot next equal to new node, tail equal to new node. This is order 1 step. Now you are not traversing from the head again and again. You are not traversing for these 5 elements again and again whenever a new integer has come. So you have stopped the iteration for the nth element, you have stopped the iteration for n minus 1 elements, and that's a great optimization. Now at every step you are doing this work, So for n elements you are doing order 1 work, so your time complexity for taking input of n elements have become order of n. Because at each step, if it was the first element, you point head and tail to that node. If it was the rest of the element, you do tail dot next equal to new node and tail equal to new node. So order 1 step is everywhere for each iteration. So your overall time complexity has become order of n. So we will not traverse from head again and again. We will maintain a reference to the last node and that we known as tail. Okay. So let's optimize it in the code as well and see if it works. So this was our previous taking input part. We will be optimizing in this. The input list will remain same, head equal to none initially, and we will maintain a tail as well now, like this here, tail equal to none, because initially let's say 1, 2, 3, 4 is here, initially head is none because you are not taking any input, head equal to none, tail equal to none. Now for current data in the input list, 1 had come, if current data equal to minus 1, so it is not equal to minus 1, you will create a node for that, 1 will be created. If head is none, since it was the first element, you will point head to this and also your tail should also point to this, because for a single element head and tail are same. That means first node and last node are same. So we will say head equal to new node, also tail equal to this new node. Okay, this part will remain same. For the rest of the part, you will do what? Now let's say next element will come, you will go here, current data equal to minus 1, no it is not, you will create a new node for that. So you have created 2 here like this. Now what you do is, if head is none, no head is not none, for the rest of the part you will do, now you will not change the head, you will not traverse to the head, you will just do, here is your tail, tail dot next equal to this new node, that means tail dot next will become like this and tail should start pointing to this. Okay, you will not traverse this part, instead of this you will do these 2 parts, that is tail dot next should become equal to this new node and tail should start pointing to this new node. Because for the next part, if the next integer come, your tail should be pointing here. Now for the rest part, you will go again, current data will become 3, you will create a node for 3 like this, new node equal to this, head is not none, you will do tail dot next equal to new node, so your tail will start pointing to this and tail will become equal to new node. So for the rest of the part, the tail become like this. 4 will come, tail dot next equal to new node, tail equal to this new node. 5 will come, tail dot next equal to new node, tail becomes equal to this new node. Minus 1 will come, current data equal to minus 1, you will break, you will return this head. Head was pointing to this only. You have not changed head anywhere. For the rest of the part, you had worked on tail only. Head is assigned when the first element had come. If no element had come, head and tail both will become none, and that should be there as well. Okay, you got the head, you print the linked list of head. That you have already seen that how can you print the linked list. I think that will remain same. Now the time complexity is order 1, because you going in each input, you do this is order 1 step, assigning head and tail to that new node, and this is also order 1 step, that is assigning tail to the rest of the elements. Okay, tail dot next equal to new node, so tail will move by 1 step at each step, at each iteration. So this is order of n solution, and we have optimized it. Let's try to run this. I think this should work. So if I give the input 1, 2, 3, 4, 5, 6 and -1, I got the linked list. I am able to print the linked list 1, 2, 3, 4, 5, 6, none. It is able to take the input, and the optimization is great because from order of n square you have moved on to order of n. Okay, so please make sure you understand this and then move on to the actual applications of the linked list, which we will be discussing in the next sessions. Okay, great. Thank you. Hi. So in this session we are going to discuss a very interesting problem, that is inserting at ith position in a linked list. Okay. So what our question is, let's say you are given a linked list like this 3, 4, 5, 1 and 2. So your task is to implement this function. You are given a linked list, that means you are given a head of a linked list in which you have to insert an element. The position is the ith which is given to you, and the data through which a new node will be inserted in this linked list is given to you. Okay, so you have to insert this data in the linked list. That means you have to insert a new node in this linked list, and you have to return the head as well. Okay, so you have to return the linked list because the head of the linked list can be changed. Okay, that we'll see how. So for now our task is to implement the function, that means insert in a linked list whose head is provided to you, at which position you need to insert, that is I, and with which data, that means the value of the node through which you will insert in the linked list is provided to you. Okay, and the range of I will be where from where to where. I think you can insert at minimum 0th position. Okay, -1, -2 is not valid, so I will start from 0 and it will range till where. So you can insert here 0, first position, second position, third position, fourth position. So you can insert at fourth position. That means if you insert 6 here, so 1, 6, 2. So this is the fourth position. Okay, so you can insert at fourth position. You can insert at fifth position as well. That means after last. Okay, so if the length is 5, then you can insert at maximum 5. 6 is not allowed. Okay, so maximum 5 is allowed. So I think the maximum I is ranging till length of the linked list. So I is ranging from 0 to length of the list. Okay, if it is outside this range, then you don't need to insert anything. Just skip all the part. You don't need to insert anything. You can insert only if you are within the range and your range is 0 till length of the linked list. Okay, so in this you can insert at maximum 5th position. That is great. Now how will we do this? How will we insert at some particular ith position? Okay, so let's see what process we can follow. So if you are given a linked list like this 3, 4, 5, 1, 2, this is I equal to 0, this is I equal to 1, this is I equal to 2, this is I equal to 3, this is I equal to 4. Let's say I give you a 2 at which you need to insert, and the value with which you need to insert is 6. Okay, so this is my data and this is the value of I. My head will be pointing here. Let's see if I want to insert at second position, what I need to make change in the linked list. Okay, so I think if I need to insert, so first of all I think I will create a node for 6. If I created a node for this, I need to make connections like this. Since I need to insert at second position, so after 4 6 should come, after 6 5 should come, like this. So this is how the linked list will get changed, and for this to happen, I think we need 2 pointers. Why? Because 6 next will be made 5 and 4's next will be made 6. So you need a pointer to a 4 and a 5. And at which position you need to insert? let's say that is current at which you will insert, and its previous position is important. Let's say it is previous. I think these two pointers are needed to insert any new node. Okay, and at the position where where you will insert, that is pointing through current, and its previous position is previous. Okay, so if I had like this 3, 4, 5, 1 and 2, let's say I keep on moving, my current comes here and I equal to 2, I becomes to the value, the I becomes equal to the value with where I need to insert. So I keep on counting. So here my count was 0, this is my 0th position. Here my count had become 1. Here my count becomes equal to 2, which is equal to I. So that means I reached a position. Here I will maintain a pointer that this is the current. I will also maintain a pointer previous, the previous position of the current. Now I know the data with which a new node needs to be inserted. First of all, I make a new node. That means I will make a node with 6. So I will make a node with 6. If I had pointed through previous like this, so I think force next should be 6. So this represents what? Previous. Previous was 4. Previous dot next equal to what? Let's say you made a new node with this reference. Let's say new node. You created a node for 6 like this. Previous dot next equal to new node. That means you had made a connection. Force next to be 6. Now your current is pointing here. 6 next should be made 5. That is for sure. So what I need to do is 6 next should be made 5. Already force next has been made as 6. 6 next should be made 5. That means new node is the reference to 6. New node dot next equal to current. Just visualize this. Just visualize this carefully. My previous was pointing to 4 and my current was pointing to 5. What I did was, I will insert 6 in between them. How will I insert? First, I will create a new node with data 6. Data 6 that we know. Now new node has been created. Then after that I did previous dot next equal to new node. That means we have removed this. I had made force next to be 6. After that I did new node dot next equal to current. That means force next was 6. New node was pointed to this. New node dot next equal to current. Current was pointed to this, and this has been made. And this has been made, and I think with these 3 lines you are able to insert at any particular ith position. Okay, so how will we insert? I think these 3 lines. How? First, new node should be created. Then this is a previous, this is a current, this is a new node. I will do previous dot next equal to new node. So this connection, previously this was this connection, this has been broken, this has been made. Then I do new node dot next equal to, so this connection has been made and this node was inserted at between this. Okay, so if I am able to do this, I think we are able to insert at every position. I will maintain a count. When the count reaches I will do these steps. It will work for every case, but it will fail for one case. Where? Let's say this was 3, 4, 5, 1 and 2. Let's say I give you I equal to 0. I equal to 0. I need to insert at this position only. Here, the current will be pointing to this, but the previous will be pointing to nothing. The previous will be none. I need to insert an element with value 6. You will create a new node, that will be done. 6 has been created. This line, previous dot next equal to new node. Previous is pointing to none, none dot next. It will give you attribute error, that there is no attribute next present in none type. So this statement will not be allowed here. Previous dot next equal to new node. No, previous is pointing to none, so you cannot point next of none. Will this line work? New node does next equal to current. I think 6 next will become what? 3. That should be there. That should be there because rest of the linked list will remain same. That should be there. This step is correct, but this step is not correct. So we will skip this step. We will check if previous is none, we will not do this. So if previous is none, I need to do different thing. else I need to do previous dot next equal to new node, and before that new node creation is same, and new node dot next equal to current remains same. Only step remaining is that previous is none here, so I cannot do this. But if previous is none, that means your head of the linked list is getting changed. Your head of the linked list is getting changed, so you have to change the head of the linked list. Before inserting 6, your head was 3. Now you have inserted 6, your head has become this. So if your previous is none, that means you are inserting at I equal to 0. That means your head is getting changed. That means your head is becoming this new node. That's why you have to return the linked list as well. In the end, you have to return head as well. Insertion will be there if it is inserting at any position other than I not equal to 0. That means you are not inserting at the 0th position. That means your head will not change. So head will remain same. Only if I equal to 0, you are changing the linked list. That means your head is getting changed. In this, your head will be updated. For the rest of the part, things will remain same. For I equal to 0, since previous is none, that means you cannot do this. That means your head is getting changed. That means you have pointed this, and we are able to do that. Okay, so we will be following these steps only. I think you are able to visualize this. All the cases have been taken. I equal to 0. Another thing, in between any position we can insert. Also we can insert at the last position. These steps will work at that step as well. How? Let's see. 3, 4, 5, 1 and 2. 0, 1, 2, 3, 4. Let's say I give you I equal to 5. I equal to 5 means current will go here. Previous will be pointing here. Let's say you want to insert 6. You created a node 6, that is here. Previous dot next equal to new node, that means previous dot next will become new node, that is for sure. New node dot next equal to current, that means new node dot next, since current is pointed to none, so current will not be here. New node dot next equal to current was none, so it will be pointing to none, and that is for sure. This is allowed. So for that all these three steps work, and your head will not change. For the rest of the work, things will remain same as well. Only when I equal to 0, you have to handle this case. In that previous will be none, your head will become new node. You cannot do this, and rest part remains same. Okay, so we have covered all the cases. I have explained you that how you need to do that. Now it's your chance to code this and submit on CodeGen. Okay, interesting approach, interesting question. All edge cases are covered. Please try to code it and submit it. Okay, great. Thank you. Hi, so in this session we are going to code the question, that is insert at ith position iteratively. So we have already discussed the approach. Let's try to code it down and let's implement the function. That is, our function is insert at the ith position. Insert at the ith position of what? Of a linked list whose head will be provided to you at the position which you want to insert, that is I, and the data with which the new node will be created is provided to you. Okay, so in this function what we need to do is we need to insert at the ith position. Okay, so let's say you are given a linked list like this 1, 2, 3, 4, 5. I give you I equal to 2, that means you need to insert here. This is 0th position, first, second, third and fourth. So first check whether we can insert or not. If we cannot insert, we need to return the same linked list. I think we cannot insert if I is lesser than 0, because minimum I can be 0 and the maximum I can be, I can insert at the length of the linked list. That means at 0th position you can insert first position, second position, third position, fourth position, also the fifth position. So you can insert at 5th position, but you cannot insert 6, 7, 8 for this part, because that crosses the length of the linked list. So you can insert at maximum length of the linked list. That means if the length of the linked list is 5, you can insert maximum at 5th position. So if I is less than 0 or I crosses the length of the linked list, you cannot do anything. You need to return the same linked list. So you will return the same head. I think this part is clear, that if I lesser than 0 or I crosses the length of the linked list, we cannot insert in the linked list. I will just return the same head. Okay, so I think calculation of the length of the linked list is also very easy. We will implement a function which will take a linked list, that means take the head of the linked list and calculate the length of the linked list. How can we do that? I think we can do that. If our linked list is like this 3, 4, 5, 1, I will pass the head to it. I will maintain a count equal to 0 initially. So head is not none, I will go head equal to head dot next, I will go here and count will become 1. Head is not none, my count will become 2 and head will move here. Head is not done, count will become 3 and my head will move here. Count equal to 4, head is not done, count equal to 4, head will move here. Now my head has become none, so count was 4, that means there were 4 elements in the linked list. So I can pass a linked list, I can traverse on that till I reach the last point. That means till I will traverse till my head becomes none, so that I will traverse all the elements, I will count all the elements parallelly and in the end I will return the count. Okay, so let's quickly write this function. That means I cannot insert if I is lesser than 0 or I crosses the length of the linked list. If I need to pass a linked list, I will pass the head of that linked list. If I cannot do that, I will just return the same head and do not work anything. I will just return the same linked list. For the rest of the part, I will implement the function that is calculating the length of the linked list like this. Calculating the length of the linked list, as we have seen, we will traverse till head is not none. I will keep on traversing head equal to head dot next, as we did in print linked list as well, that we traverse on each element of the linked list. Okay, so while head is not none, head equal to head dot next, I will maintain a count which initially will be 0. I will keep on incrementing the count as soon as I reach any of the element. When head becomes none, I have crossed all the elements, I have this count, I will just return this count and this function will give me the length of the linked list. Okay, this is done. That means if I is lesser than 0 or I greater than length of the linked list, I cannot insert it. If I come down, that means I can insert. I am sure that I can insert now. If I need to insert at ith position, I need to reach that ith position first. Okay, so what I am suggesting here is, since you have traversed on whole linked list, now you need to traverse till you reach the ith position of the linked list. So this is 1, 2, 3, 4, 5. If I have given you I equal to 2, that means you are here 0, 1, 2, 3, 4. So again you can reach the ith position by maintaining a count. You will say that initially I am at 0th position. Count is not equal to I, you will go count equal to count plus 1. So count will become equal to 1 here. Count is not equal to I, you will go to this position. So count will become equal to 2 here. Since count becomes equal to I, so you will stop here, you have reached the ith position. Now you will do your work. So first let's reach the ith position, then we will see that what we need to do. So first reach the ith position means, for reaching the ith position, I will again maintain a count that initially I am standing at 0th position. I will traverse till I reach the ith position. That means I will keep on traversing till I am lesser than the ith position. Okay, and I will keep on incrementing count equal to count plus 1. When count becomes equal to I will come out of the loop. That means I need to insert at ith position now. Okay, that I have done, that I have reached the ith position. If I have reached the ith position and if I have given a data like this, so what we need to do is, we have discussed that we will maintain two references, one is previous and one is current, because you need to make changes like 2's next should become 6 and 6 next should become 3. Okay, so you need to have the previous pointer as well and the current pointer as well, so that we can maintain parallelly while we are reaching the ith position. Okay, as soon as we reach the ith position, we have a current which is pointing to the element which is currently present at ith position, and we will have a previous just previous to the current position. So what I am saying here is that you can do like this: 1, 2, 3, 4, 5. Let's say your I equal to 2 here. You are standing at 0th position first, so your current will be head here. Initially you can assign current to be head and previous to be none. Because if I have given I equal to 0, your current will be head and previous should be none. That should be sure. Okay. Now when you will moving here to here like this, so while moving here to here, what do you need to do? I think your current will be moving here and your previous will be moving here. That means current will be moving here, means current will be becoming current equal to current dot next. Previous will be moving here, that means previous is moving to the current position. Then you have reached here, again count is lesser than I, so you will be moving here. That means your current will be becoming current dot next and your previous will be becoming this current. But I cannot write like this, current equal to current dot next, and then assign previous equal to current. Order of statement is important. Why? Because if you did like this, current equal to current dot next, that means current will move here. Now you have done previous equal to current, that means your previous will also move here. You don't want this. You want what? If your current is standing here and your previous is standing here, then before moving current equal to current dot next, you need to move previous to here, and then you can move current equal to current dot next. Okay, don't move current first move previous to current and then move current to current dot next. Okay, that is the difference of execution of statement. This is very important in case of linked list. Okay, all the errors come because of the order of the statements. So make sure you dry run and see that I need to move current first or I need to move previous first. In this case, I need to move previous to current first, then I will move current to current dot next. Okay, so I will do like this. When I am moving to the next position, so I will do previous equal to current and current equal to current dot next for sure. Initially, before doing anything, previous will be none and current will be pointing to this end. Okay, why we have maintained current? Because we don't want to lose the reference of head. In the end of every work, we need to return the head of the linked list. Okay, so don't lose the reference of head. Maintain two pointers, previous and current like this, and we have maintained like this. When we will reach the ith position, I have a previous and a current of that position. So that means I will have like this, that if I 1, 2, 3, 4, 5, my current will move here and previous had come here, I equal to 2. Let's say I provide you the data 6. So first you will create a node with this data, because actually we have maintained the linked list of nodes. Okay, every element of the linked list is a node. So first, after coming out of the loop, we have reached the ith position. Now we know that we can insert that element, and if we want to insert, we will create a node for that. So new node will be node of this data. First node will be created. Then I think since you need to insert in between these two nodes, so what you need to do is you need to lose this reference. So 2's next should become 6. That means previous dot next should become this new node, and 6 dot next should become this current. That is for sure. Okay, so that means 6 next should be made 3. So that means new node, this is my new node dot next should become equal to this current. Okay, 6 next should be 3 and 2's next should be 6. So after creating the new node, I need to write these two statements, that previous dot next should become equal to this new node and new node dot next should become equal to this current. If I am done with this, I need to return the head of the linked list after that. So I will just return this head. I have a previous, I have a current, I have maintained all of them, and I have made the connections as well. Now I think this part is clear. The only point remaining is this will work for every case, but it will fail for one case. That case is if I have given you I equal to 0. What will happen in that case? 1, 2, 3, 4, 5. I have given you 6. I insert at position 0. So your count will be 0 initially. Previous will be none. Previous is none here. Current will be pointing to this side. Count equal to 0. While count is lesser than I, 0 is lesser than 0. No. So this loop will not run. You will come downwards. You will create a node for that. So that means node for 6 will be created. This part is correct. Previous dot next equal to new node. Previous is pointed to none. None dot next will become 6. That is not allowed. This is only allowed if previous is not none. So that we have already discussed. So I can do this only if previous is not none. I can only do this if previous is not none. If previous is none, then I need to do something different. If previous is none, that means my new linked list will be becoming like this: 6, 1, 2, 3, 4, 5. You will not be changing the previous. Instead, your head will be getting changed. So instead, previous dot next should become new node. I can show, since I am inserting at 0th position, that's why my head will get changed. So my new head will become this new node. Will this step work? New node dot next equal to current? Yes, it will work. Because since you were inserting at 0th position, current was pointing to 1. You have made a new node like this. You have pointed the head to this. After this step, you need to make 6 next to be 1 as well. So that means new node dot next equal to current. This is correct. This order is important, that if previous is not none, you need to do previous dot next equal to new node. That is for sure. If previous is none, that means you are inserting at 0th position. That means you will make head equal to new node. Okay, so in this case your head will get changed, and in that you have returned head. So accordingly, if the head will get changed, you will return the new linked list. If it does not get changed, you will insert the new element in the linked list and return the previous head only. Okay, so this is how we have inserted. I think this should work fine for every case. Let's try to run this for covering all the cases. Let's say I have taken input of the linked list. I will print that linked list first. Then I will insert at ith position. Let's say I will insert at second position with value 6, and the linked list which is like this. So I will insert at the ith position and I will get the linked list as well. I am storing in head only. After that I am printing this head. Then again I will be inserting at some position. Let's say insert at ith head comma. I am inserting at 0th position with value 9. After inserting the value 9, I will print the linked list again like this. So now if I try to run this, I will pass the input 1, 2, 3, 4, 5 and -1. I am first inserting at second position, so the linked list would have become like this: 1, 2, 6, 3, 4, 5, none. I am inserting at 0th position, so the linked list has become 9, 1, 2, 6, 3, 4, 5, none. That is correct. Let's insert at another position, let's say last position. So the last position which you can insert it is length of the linked list. So the length have become 1, 2, 3, 4, 5, 6, 7. So let's insert at last position as well. Insert at ith head comma, the length of the linked list will be 9, 7 and 9th, and let's say the value is 10. So once again I will print the linked list after that again. So let's insert 1, 2, 3, 4, 5 -1. So I have inserted 1, 2, 3, 4, 5 none. Then insert at second position 1, 2, 6, 3, 4, 5 none. Then inserted at 0th position 9, 1, 2, 3, 6, 3, 4, 5, 5 none. Then inserted at 7th position. So this had become 9, 1, 2, 6, 3, 4, 5, 10 none. So this is working for every case. I think this is a perfect solution, and we are able to insert at ith position. Okay, make sure to try it yourself. Make sure to try run for few cases. Make sure to understand that how things are going. Okay, great. Thank you. Hi, so in this session we are going to discuss the problem insert at ith position in the linked list, but this time we are going to discuss recursive solution. Okay, so our question is, you are given a linked list like this 1, 2, 4, 7, 6 like this. You are given a head of the linked list in which you want to insert. You are given the position where you will insert, and you are given a data through which you will create a node and insert that node in this linked list. Okay, so you have to do it recursively. So let's say 2 is given to you, and let's say 8 is given as data. So this should become, so this is 0th position, first position, second, third, fourth, like this. So at second position means this linked list should have become like this. This is the expected output after that. Okay, so how can we do it recursively? So our function is insert head I comma data like this. So in this linked list I need to insert at what? Let's say I equal to 2 is given to you. In this linked list, starting from this head is pointing here, you need to insert at I equal to 2. So that means this position, and data is provided to you. What induction hypothesis you can make is, I think you can make that, hey, on this part of the linked list, that is 2, 4, 7, 6, whose head starts from here, I need to insert at, if in this linked list I need to insert at second position, then in this linked list I need to insert at first position. So here I equal to 1 here. for this linked list which is whose head is starting from here. This is the induction hypothesis you can make. What this will say is, hey, I want to insert starting from this linked list, I need to insert at I equal to 0. This is the induction hypothesis you can make. You can make a call, hey, get me the linked list by inserting at the 0th position of this linked list. Hey, get me the linked list by inserting this data, the new node with this data at first position of this linked list. This will solve your problem. So your problem depends on a smaller sub problem, and your smaller sub problem is that, hey, I want to insert at ith position, so I will call head.next, because new position is head.next. I need to insert at this in this linked list whose head starts from here, so its head is head.next. If my head is here, head.next will be here. I need to insert at I minus 1 position. If it was my second position, then in that linked list it is first position. If that is the first position in this linked list, that is the 0th position in this linked list, and the data will remain same. So this step will remain same. This is the induction hypothesis you can make. Your problem is you need to insert at ith position of the linked list whose head is here. You have solved this problem by calling this a problem, which is you will insert at head.next, that is this head, and in that I minus 1 position with this data. This is the induction hypothesis you want. Okay, by doing this will insert at that position. Now you will keep on doing it until which position you need to do it. You have come here 4, 7, 6. Will you say that, hey, insert at, you were told to insert at 0th position in your linked list? You will say 7 to 6, insert at minus 1 position. I think that doesn't make sense. I think at 0th position you need to handle. At 0th position you need to handle it. So for 4, 7, 6, if your data is 8, you need to convert this linked list. Inserting at 0th position is very easy. Create a node for 8, make its next to be 4, and return this as your new head. Because 8, you need to insert at 0th position of this linked list with the data 8. First you will create a node with data 8. You will make its next to be 4, and you will return this head. For 0th position you can solve, and that will be your base case. Your base case will be if I becomes equal to 0. Because at 0th position you can solve the problem. You do not need to solve the sub problem. You can just solve your problem there and return the head from there. Okay, so I think we have discussed that up till now, that if my head is here and I need to insert for head for position I with a given data, I will call insert, let's say I'm writing here insert in next part of the linked list, that is head.next, at position I minus 1 and the data. And the point is I need to get the head of that linked list as well. I need to get the data of that linked list as well. Why I am saying this? Because this will call on 2, 3, 4, 5, 6. Let's say your position was 2. It will call for position 1. It will call on 3, 4, 5, 6 with position 0. Now you have come to position 0, you will handle your base case here. So that means if I becomes equal to 0, you can already do the answer. That means you will create the new node with this node data. You can easily create the new node. Let's say your data is 8. So you will create the new node here. You will make new nodes not next to be head, because here head is this. So that means you will make that new node dot next equal to head, and this is done. And 2, 3, 4, 5, 6, you have told this to insert at 0th position 8. So it had come with 8, 3, 4, 5, 6. So it will return you this head. So what I am saying here is you will need to make 2's next to be 8. Currently 2's next is 3, that you don't want, because you have called this sub problem to insert 8 at the 0th position of this linked list. This had returned the linked list like this, whose 0th position is 8. So you need to get the head from there. So that's why you are returning the head. If you got the head, what you need to do? You have called this sub problem for 2 here. You have called the sub problem for 2. You got the answer here. You got the head from here. you need to make one change, that this was your head in this problem. You will make its heads next to be 8, not 3. You will remove this, because now since you have called this problem to insert 8 at 0th position, it had returned the linked list with this. Whatever head is returned, you need to make it as next of 2. So that means you need to make head dot next equal to small head, and your head is only this head, so you need to return that head only. But this step is important, because whatever head is returned here, you need to make it as next of that. Here, if I equal to 0, you had made new node equal to this, new node not next to be head, and you will return this new node as your head. So here your answer will be return new node. So 8 will be returned, 2's next. Here you got the small head through which 8 will be returned. You got the 8 in small head. You made head dot next equal to small head. You had made the connection like this. So 2, 8, 3, 4, 5, 6 has been done. You will return this head. 2 will be returned. So one head called to insert 8 at first position in this linked list. It had returned the linked list like this: 2, 8, 3, 4, 5, 6. It had returned this head. This will be in the small head. You will make one's next to be small head. That is already there. That is no problem. You will make the same connection again, head dot next equal to small head, and return this head, and your linked list has been made. So that's a great thing you can solve, that if I equal to 0, you need to insert at 0th position. That you will handle like this. This is your base case. For the rest of the position, you will get the head of the linked list at which you have called to insert at I minus 1 position, get that head. Whatever head you get, you need to make that head as next of yours. You had done that, and in the end, you just return that. Okay, so this was done. One more thing, that there may be a possibility that I was given 1, 2, 3, and let's say I equal to 5 has been given to you. So what you will do in that case? So here you will call for 2, 3 to insert at 4th position. You will call 3 to insert at 3rd position. 3 will call on none to insert at 2nd position. Now here at dot next will give you error, because none dot next doesn't happen. I does not become 0. I equal to 2 here. You will go here, insert at head dot next. That will give you a problem, because none dot next doesn't happen. So that means if at any point of time your head becomes none, that means you can do nothing. You just need to return none from there. You just need to return none from there, because that doesn't make sense. If you can only insert from 0 till the length of the linked list. That is your range. You cannot insert at the position greater than the length of the linked list or lesser than 0. So lesser than 0 or whatever position, if head becomes none, you just need to return none from there. Okay, so you cannot do anything from there. So you have just done that, and your answer will be there. The point is, if I is less than 0, what do you need to do in that case? If I give you -1, -2, you just need to return the same linked list. Okay, in that case you just need to return the same head. Okay, you cannot do anything, you will just return the same head again. Okay, that is the same thing, rest will be done. I think the approach is clear, that what we are following is, we are following, let's say 1, 2, 3, 4 here, I equal to 2 here is given to you. You will call 2, 3, 4 to insert at I equal to 1. You will call 3 to 4 to insert at I equal to 0. Let's say your data was given to be 9. You will create a new node 9 here. You will make its changes to be 9, 3, 4. You will return this as your new head. 2 will get answer from this as 9, 3, 4. You will make 2's next to be 9. You will return 2, 9, 3, 4 to this, and after that you will get 2 from here. You will make 1, 2, 9, 3, 4, and you will return this as your new head, and this has been done. Okay, this is the approach we are following. I think there is a very simple approach. Now you can try the code yourself. We will be coding this in the next session. Please try yourself and then move on further. Okay, great. Thank you. Hi, so in this session we are going to code inserting at ith position recursively. Okay, so we have already discussed the approach. Let's try to code it and then try run it. So our code was like this. We need to implement we have already done insert at ith iteratively. Now our task is to implement insert at ith recursively. Okay, we will have a head, I and data like this. When I come to a node, when I come to any element that is head, when I come to any head of the linked list, for any ith position if I need to insert, what we have discussed is, the induction hypothesis is, hey, let's insert at which position? Insert at ith position recursively I will call this function to insert at I minus 1 position of the next part of the linked list, like this. We have called this. What I'm saying here is, let's say 1 2 3 4 5 is here, my head is here, let's say I equal to 3 is given to you, that means you need to insert at third position. What I'm saying here is, hey, and let's say data is 9 here, hey, insert at second position of this linked list, that means whose head is this, head dot next is this, head will move on here, you will get to a problem like this, and this you need to insert at second position, okay, and get the head of that. Okay, why? Because you will call this will call further, insert at ith position recursively on 3 4 and 5, insert at first position in this linked list whose head is this will call on 4 5, insert at 0th position on the linked list whose head is this. Now for 0th position it cannot call for minus 1 position, so you will, for I equal to 0, you will do what? I think for I equal to do 0, we can already do that. I becomes equal to 0, I can do that. I will create a node for this, that means 9, new node will be created. First I will create the node for this like this, that new node is node with this data. I created the node, I need to make 9's next to be 4 and I need to return 9 as the new head. Okay, so I will make first that new node dot next, since I am inserting at 0th position, so head is this, so that means new node next to be head. So I will do new node dot next equal to head, and what I will return is this is the head of the new node, head of the linked list, that means I will return new node. Okay, so my new head is this, return, and what I am saying here is you need to get the head of for the linked list, that when you have inserted at this position, what is the head of that? What this will do is you will get the head of the linked list after inserting at I minus 1 position of that part of the linked list. So that means 1 2 3 4 like this, you have inserted at I equal to 3 and with data 9, it is called on 2 3 4 5, I equal to 2 here with data 9, it is called on 3 4 5, I equal to 1 here with data 9, 4 5, it had made 9 4 5, it has returned you as this head. So this call will get from 4 5 what? The new head, that means 9 you got, you need to make, currently 3's next is 4, you need to make 3's next to be 9, so that means you need to get the head of that, whatever new head you got, you need to make that head to be the next of your head, that means head dot next equal to small head, and you need to return your head after that. So that means you will make 3's next to be 9 and this will become 3 9 4 5, your head will remain this only, you will return this, so that means 2's next will become 3 only, that will remain same, so it will become 2 3 9 4 5, it will return to 1, it will become 1 2 3 9 4 5. If I had given you initially 0 only, what it have been done, so at I equal to 0, let's say you want to insert it with data 10, so you will come to I equal to 0, you will create a new node with data 10, you will make 10's next to be 1 and you will return this as your head. Okay, so all the things are working fine. One thing which we have discussed, that if at any point of position, if at any point I becomes less than 0, that means I have given you what? Negative, minus 2, minus 3, that doesn't make sense. You don't need to do anything, you just need to return the same linked list, that means return the same head. Okay, if I had given you what? Negative positions. So let's move it above, that if I is lesser than 0, we cannot do anything, I will return the same linked list. The point is, if at any point of time head becomes as none, that means your I was more than the length of the linked list. Why? Because let's say you had 1 2 3 and I had given you I equal to 5, so it had called on 2 2 3 with I equal to 4 with this head, it will call on 3 with I equal to 3 with this head, it will call on none with I equal to 2. Now here head is none, you cannot call on head dot next, that means you cannot do this, you need to stop, you cannot do anything, you will just return none from there, because I am not changing the linked list, so it will return none. So 3's next will remain none, it will return head as 3, 2's next will remain 3, 1's next will remain 2, 1 2 3 will remain same, you cannot do anything, you will just do return none from here. I will return none from here. And why I have written it below I equal to 0? Because we can insert at I equal to length of the linked list. So what I am saying here is 1, 2, 3 is here, right? I can insert a third position at this linked list. Let's say I have given you data with 9. So it will call on 2 to 3 I equal to, let's say 3 here. So it will call on 2 to 3 with I equal to 2 with data 9. It will call on 3 I equal to 1 with data 9. It will call on none with I equal to 0. So if I had written it above, if head is none, that means it will return none. But that does not need to be happen, since it had come to none but I equal to 0 is there. At an empty linked list, you need to insert at 0th position. That is allowed. So you need to write I equal to 0 before head is none. Why? Because head is none here and I has become 0 here. So you can create a linked list. That means you will create what? You will create a new node with data 9. You will return new node not next equal to head, because your head is none. So 9 next will be none. You will return this 9. Okay. So this should be written below this, because if head is none and I equal to 0, that means there is an empty linked list at which at position 0 you need to insert, that is allowed. So you will write I equal to 0 before head is none. So we have written this. For this part you are done, and I think we have handled all the cases. Now you can try for each step. This part is done. We will be calling this insert at ith recursively here. Now we will be following the same step. Let's say we call for 1, 2, 3, 4, 5 and -1. So we have got here 1, 2, 3, 4, 5 none for first. Then you have inserted 1, 2, 6, 3, 4, 5 at position 2. At position 0 it is 9, 1, 2, 6, 3, 4, 5. At position 7 and 10 it has already been inserted, and I think rest part is done. So it is working fine for every case. We are able to code it. We are able to insert it recursively as well. Both the approaches are correct. Try to see the time complexity of both the solutions. We will be analyzing that in the next session. Please see the time complexity of both the questions, both the approaches. Both the approaches are correct, and I think you should understand that we can apply both the approaches and solve the question. Okay, so make sure to understand both the recursive and iterative approach. They are very helpful in most of the questions of linked list. Okay, great. Thank you. Hi. So in this session we are going to analyze the time complexity of our inserting at ith position question. So we have done by two things. One was iteratively and one was recursively. Okay, so this was our solution and this was our iterative solution. If we analyze the time complexity for this, if we are implementing this function, first we do I less than 0 or I greater than length of head. I think this length function takes order of n time, if n is the length of the linked list. Okay, n is length of the linked list, so you take order of n time here, that is length of the linked list. Then you do work count, then you do the work how much time? Count lesser than I times. So you do iterate for order of I. Okay, I is what? Where the I is the position where you need to insert the element. So you take order of I here. You had taken order of n in calculating the length of the linked list. Rest part is order 1, because you do this part. This part is order 1. If new node equal to creating a new node, assigning some connections, these all are order 1 part. This takes order of I and this takes order of n. So overall time complexity will be, since I in maximum can be length of the linked list, so we can say order of n. Okay, order of n is here, I is here, so I think maximum is order of n. So we can say our time complexity of iterative solution of inserting at ith position is order of n. Okay, let's see the recursive solution as well. So in the recursive solution we have done something like this: head, high, and this. For any recursive solution inserting at ith position, what we do is, if this is our linked list 1, 2, 3, 4, 5, 6 and this is our I, what we do is, standing at here we call, hey, insert at I minus 1 position in this linked list. So we call for the rest of the part of the linked list, and we keep on calling till our I reaches 0. So I think what our iteration is, t of n is t of n minus 1 plus in each call you do like some assignment. Okay, some connection is making here, rest of the part is order 1. So you do order 1 work here. You do t of n minus 1 as t of n minus 2 plus some order 1 work. You keep on doing this till how much time? Till the ith iteration. So these calls will be made. If I becomes less than 0, you do nothing. So maximum these can be done how much times? I times. So our time complexity is order of I in case of recursion, because if head becomes none, that means you have traversed all of the linked list and I was greater than n. So again order of I is here, but if the length I has given you the greater than the length of the linked list, then obviously you do order of n time or order of I time. Okay, because I crosses greater than n, so you don't do that part, you just return none from there. So effectively we can say our time complexity is around order of I in case of recursion. Okay, so this is our time complexity, just for your information, that iteratively, just because of calculating the length of the linked list, we takes order of n time, but in case of recursion we do these recursion steps only I times. Okay, because I keeps on decrementing till it becomes 0. Okay, so our overall will be I steps, so we can say that our time complexity in case of recursion will be order of I. Okay, so that is about time complexity. It's your task to do the next question relating to the deleting part. So try to attempt it, and this is almost similar to inserting the ith element at ith position. Okay, so all the best for that, and make sure to understand this concept. Okay, great, thank you.
Hello friends. So in this session we are going to discuss a simple problem from linked list. Okay, so what is the problem? Problem is I have to print the ith node. Okay, so there is a linked list of say integers. It can be any linked list of anything. Say I have numbers, say 5, 4, 9 and -2. Okay, and I have to print the ith node where I starts from. So this is the 0th index. This is 1, 2, 3. Okay, so my node are indexed. The indexing starts from 0. I am given a linked list. So how would I be given a linked list? I would be given the head pointer, and from head I can traverse to any node, and I am also given some I. So my I can be 0, 1, 2, 10, 100, anything. So I have to go to that ith node and print that node. Alright. So how would we go about the how would we go approach the problem? So we would start from head and we would traverse in the forward direction, trying to reach to the ith node. Okay, so we will have our current, which would be pointing to the head node, and we would traverse the nodes one by one, and we would keep on increasing the count, wherein count would be 0. So I am at the 0th node, then the first node, then the second node. So in each iteration I would increment the count as well as the current pointer, so that I reach the ith node. Okay, what I need to ensure is that my current should not be null, and because if current is null I cannot go forward. Okay, and my count should be less than I, because if my count is equal to I am at the ith node and I can come out of the loop. Okay, so up till the moment where the count is less than I and current is not null, I need to traverse. Okay, so what I'm doing is, so I'm checking for two conditions. First condition is count is less than I, and second condition is cur is not null. Okay, so I will come out of this loop if either cur is null or count is equal to I. So if cur is null, then it means that there is no such node. Okay, so maybe if in this case I'll try to reach the 7th node, I will only be able to reach 0, 1, 2 and 3rd node. So beyond 3rd node I would not be able to reach, my curve would become null and I would not be able to reach there. So if there is no such node, then I don't have to do anything. If such a node exists, then that node would be pointed to by cur, and I simply need to print the data present at the cur. Okay, so I can simply print whatever is the cur is pointing to. So this is again a very simple problem. Hopefully you have understood it and you will be able to do it. Thank you. Hello friends. So in this session we are going to discuss a problem from linked list, and that is I have to delete a node from the linked list. Okay, and so there is a linked list. It has some nodes and I want to delete a node. Okay, so I hope you all know what a linked list is. A linked list has a head node and let's say the values are 4, 2, -5, 15, -6. Okay, and this is pointing nowhere, this is pointing to null. Okay, so my list has some nodes. I have a head pointer and I need to delete the node. Okay, so which node do I have to delete? That would be specified by the index. So I will get an index, say 3. Okay, and my indexing for the node starts from 0. So 0, 1, 2, 3 and 4. So I need to delete the node which is present at index 3. So what I need to do is I need to delete 15. Okay, so how should I go about the problem? Do I need to locate the ith node? So do I need to reach the node which is at index 3? So what in case I have my cur pointing at index 3? What would I be able to do next? How would I delete it? I will delete it, but what I need to do is I need to make sure that the previous node has updated this pointer. So I need to make sure that the previous node next pointer is updated appropriately. Okay, so my -5 should now point to -6. So this is what I need to do. So I don't need the access to the current node, but I need the access to the previous node. Okay, so we need to understand that we need to reach the previous node or index -1th node to delete the ith node. Alright, so I can have a pointer say such as cur and I can update it, or maybe I can name it as previous because this would be the previous node. So instead of cur I can name it as previous, and my previous would point to index -1th node. So I have to increase previous and I have to go till previous is equal to previous is pointing to I-1th node. Okay, so now once I have moved to I-1th node, what do I need to do next? So I have to do two things. First is that I have to delete this node, and I also have to make sure that my previous the next pointer for my previous node is pointing to the right place. Okay, so I need to before that I also need to check if my current node exists or not, because it is possible that my previous is valid, so previous is pointing to a node, but maybe this is null. So then I don't need to do anything because the node already doesn't exist. So I need to check if previous is valid, is pointing to a valid node, then only I can delete it. Okay, so I'll make that check. If the node exists, maybe I can capture that in current. So my current is the node to be deleted, my previous is the node which is to be, so which is the previous node for my current node, and I also need the next which is what is current pointing to, and maybe I can capture that in next. Why do I need next as well? Because after deleting the current node, my previous next would point to the next node. My previous next would point to the next node, and so we need a reference for next as well. Okay, so we need previous, current and next. So if I have these three pointers, I can very easily solve this. All I need to do is previous dot next is equal to next. So I have eliminated this and I have moved this to the next pointer, and then I can do delete on current node. Okay, but make sure that the current node exists. If the current node exists, then I can do this. All right. Another simple thing that we might be interested in is when I is 0. So when the index is 0, all I need to do is I need to remove the head node. So there would be no previous node in this case, and I simply have to move my head, and I have to clear this part of the memory. Okay, so I need to call delete on this node, and I need to update my head appropriately. So this can be a special case wherein I is 0, the index is 0. Another thing which need to ensure is what if I is pointing to a node which does not exist. So for this list, if I is 10, okay, so if I is 10, I would not be able to reach to the 9th node. So the 9th node does not exist, so how would I reach? So previous would be pointing to null, so there would be nothing to do. Also there could be cases wherein previous is pointing to the valid node, but the next node does not exist. So we have to make sure that we cater to all these conditions. Okay, so please try this at your end. Hopefully you are able to understand so we need to make sure that we understand what is happening behind the scenes when we are writing code, and what are all the possibilities which we have to consider to make sure that we are able to solve the code. Okay, thank you.
हेलो एवरीवन, सो आई होप सबका इंसर्ट नोड एट ith पोजीशन रिकर्सिवली हो गया है। इस वीडियो में आई जस्ट वांट टू डिस्कस द नेक्स्ट प्रॉब्लम, दैट इज डिलीट नोड फ्रॉम ith पोजीशन अगेन रिकर्सिवली। हम उसकी अप्रोच डिस्कस करना चाह रहे हैं, ठीक है। सो क्या होगा, सेम हमें यूजर से एक लिंक लिस्ट मिलेगी, लेट्स से दिस इज माय लिंक लिस्ट, एंड एक पोजीशन मिलेगी, लिंक लिस्ट की जगह हेड मिलेगा और पोजीशन मिल गई 2। हमें क्या करना है, हमें अपने इस लिंक लिस्ट में से सेकेंड वाली नोड को which is this node, इसे हमें डिलीट करना है और अपडेटेड लिंक लिस्ट रिटर्न करनी है, एंड वी नीड टू डू दिस रिकर्सिवली। अगेन क्या करना चाहिए, रिकर्जन जब यूज करना है तो बहुत अच्छी तरह से पता है हमें। फर्स्ट वी शुड ब्रेक आवर प्रॉब्लम इनटू 2 पार्ट्स, 1 and n-1। तो हमने अपनी प्रॉब्लम इस तरह से ब्रेक कर दी। नाउ दिस इज आवर पार्ट एंड दिस इज रिकर्जन्स पार्ट, ठीक है। चलो प्रॉब्लम ब्रेक हो गई, समझ आ गया हमारा कौन सा पार्ट है और रिकर्जन का कौन सा पार्ट है। नाउ वी शुड थिंक अबाउट द 3 स्टेप्स ऑफ रिकर्जन। फर्स्ट स्टेप इज बेस केस। बेस केस क्या होना चाहिए, बेस केस क्या होना चाहिए, जब हेड नल पे हो जाएगा, जब हेड नल हो जाएगा, इफ माय हेड इक्वल नल आई शुड सिंपली रिटर्न, मुझे सिर्फ नल रिटर्न करके बाहर आ जाना चाहिए, क्योंकि अगर हेड नल हो गया तो हम कुछ डिलीट ही नहीं कर पाएंगे ना, हमें बस बिना कुछ किए बाहर आ जाना है। दैट शुड बी माय बेस केस। ओके, ठीक है, हेड बेस केस समझ आ गया। नाउ व्हाट, 2 स्टेप बच गए। वन इज आर स्टेप, आर कैलकुलेशन पार्ट, एंड अदर इज रिकर्जन पार्ट, जहां पे रिकर्जन को कैलकुलेशन परफॉर्म करनी है। हमें पता है हमें कैलकुलेशन सिर्फ इस पार्ट पे परफॉर्म करनी है। इस पार्ट पे कैलकुलेशन कब परफॉर्म होगी, सिंपल है, जब आई की वैल्यू 0 होगी, उसी केस में तो उसे डिलीट करना है। तो हम क्या करेंगे, चेक कर लेंगे क्या आई की वैल्यू 0 है। इफ यस, आई विल अपडेट माई हेड, डीएलोकेट दिस नोड एंड विल रिटर्न द अपडेटेड हेड। दिस शुड बी आर कैलकुलेशन पार्ट। सेकेंड स्टेप डन, सबसे पहले बेस केस डन, फिर आर कैलकुलेशन पार्ट डन। उसके बाद क्या, बस रिकर्जन कॉल करना है हमें। रिकर्जन को क्या देना चाहिए, हेड की जगह हेड का नेक्स्ट देना चाहिए, क्योंकि रिकर्जन की लिंक लिस्ट 1 से नहीं 2 से स्टार्ट हुई। जैसे हम एरे में ए की जगह a+1 पास करते थे, लिंक लिस्ट में हेड की जगह हेड का नेक्स्ट, और आई की जगह फिर से जैसे हमने इंसर्शन में देखा था i-1 पास करना चाहिए, क्योंकि रिकर्जन के लिए इंडेक्सिंग इसकी 0 होगी, इसकी 1, दिस इज 2, दिस इज 3। सो जो नोड हमारे लिए 2 पर है, रिकर्जन के लिए वो नोड 1 पर है, तो विल पास i-1 आई के प्लेस पे। रिकर्जन हमारे लिए क्या करेगा, इस नोड में से रिक्वायर्ड नोड को डिलीट करके अपडेटेड हेड हमें लाके दे देगा। तो हमें इस नोड का एड्रेस रिसीव कर लेना चाहिए किसी वेरिएबल में, एंड उसके बाद ऑब्वियसली कनेक्ट कर देना चाहिए अपने हेड के साथ, ठीक है। और ऐसा करने से हमारी लिंक लिस्ट का रिक्वायर्ड नोड डिलीट हो जाएगा, एंड वी शुड देन रिटर्न द अपडेटेड हेड, ठीक है। ओके, थैंक यू।